Good afternoon children and welcome to mathematics class. Today's topic is problems on quadratic equations. Children, quadratic equations can be used to solve number of problems based on different units of mathematics, like problems on number systems, on two-digit numbers, fractions, speed, distance and time, problems on mensurations, that is different units of mensurations, age problems and so on. Solving of quadratic equation involves two steps. First, you need to translate the word problem into an algebraic equation using one unknown variable. Normally we take it as x. And secondly is to solve that quadratic equation either by factorization method or by using the formula method. So you have, this is the method of solving a problem on quadratic equations. Now let's begin by taking the problems on number system. I have taken question number 2, part 2 from exercise 5.5. The question goes as this: find two consecutive odd numbers such that sum of their squares is 394. So children, you know how to take two consecutive odd numbers. So we'll take, let the numbers be x and x plus 2, where x is odd. If x is even, then you will get this as even number. So whenever you're taking two consecutive odd numbers or two consecutive even numbers, the numbers are taken in terms of x as x and x plus 2. But if you're taking odd number, you should write x is odd. And if you're taking x is two consecutive even numbers, then you write here x is even. Now the next part is sum of their squares. Sum of what? Sum of their squares. Need to find the sum of what? Their squares. Squares means x square and x plus 2 whole square. Sum of their squares is equals to how much? 394. So this is the equation which is being framed. The word problem has been converted into an equation which you have to solve, get by solving it algebraically. So what do we get here? X square plus square of x plus 2 is x square plus 4x plus 4 is equals to 394. Now, what do you get from here? 2x square plus 4x, and when 394 comes to the left hand side, to equate it to 0, you know the quadratic equation, one side is equated to 0, we get here minus 390. Now, we reduce this, every equation should be reduced to lowest term, so we can divide this equation by 2, being a common factor, we get x square plus 2x minus 195 is equals to 0. Now, this is a quadratic equation that we have got. We have to solve this. So, I use the factorization method. The product here is minus 195 and the sum required is 2. So, I find out the factor of 195 by dividing it by 5. We get 5 3s are 15 and 5 3s are 15 and 5 9s are 45. Then I divide by 3, I get 13. And 13 is a prime number, we get 1. Now, through this combination of 5, 3 and 13, I have to find out the result to be 2x. So, I see that is 15 into 13. 15 into 13 will be 195 and 15 minus 13 will be 2x. So, I write here as x square plus 15x minus 13x minus 195 is equals to 0. And then I take x common in the first two terms, factorize by splitting. That is, I have split the term and then I am taking it x common in the first two terms, that is by grouping, we get x plus 15 and minus 13 I take common here, I get x plus 15 is equals to 0. 13 15s are, you can see 13 into 15 is 195. So what I get here from now, x plus 15 times x minus 13 is equals to 0. So we get x equals to 13 and minus 15. So we are talking about two consecutive odd numbers. So we take in terms of 13 and minus 15. So we talk about 13. So one of them is 13. If one of the number is 13, the second number will be 13 plus 2, 15. Okay? And since they have not mentioned it to be natural numbers, so we can even take from minus 15. If one of the number is minus 15, the second number will be minus 15 plus 2. Minus 15 plus 2 is minus 13. Okay? And you can see the sum of the squares. And sum of the squares of this will also become plus. So it is turning out to be 394. So this is the solution. This is the answers. Okay. Moving on to question number 3. the sum of two numbers is 9 and the sum of their squares is 41. Taking one of the number as x, form the equation in x and solve it to find the numbers. So we begin with the first statement which says the sum of two numbers is 9. So initially if you take the number x plus y equals to 9, and since then you can express y as 9 minus x. So we can write let the numbers be x and 9 minus x. Because sum of the number was 9, so y can be expressed in terms of 9, so we get in terms of one variable, x and 9 minus x. Again the question is same, sum of their squares. Sum of what? Sum of their squares. So we get x square and here we get 9 minus x whole square is equals to 41. Now if I simplify the equation, I get x square and square of 9 minus x is 81 minus 18x plus x square minus 41 is equals to 0. I brought one side of the equation equal to 0. Now when I simplify, I get 2x square minus 18x plus 40 is equals to 0. Plus 81 minus 41 is plus 40. I see the 2 is a factor of this equation, so I take 2 divided the equation by 2. I get x square minus 9x plus 20 is equals to 0. Okay, and I know that product here is 20, sum required is minus 9, and these numbers are smaller numbers, so I don't have to do factor like this. I can directly find numbers to be minus 5 and minus 4. 5 4 is 20 and minus 5 minus 4 will give the sum product as plus 20 and the sum will be minus 9. So I replace it here as x square minus 5x minus 4x plus 20 is equals to 0. I take x common, I get x minus 5 minus 4 common here, x minus 5 is equals to 0. So solution of this equation will turn out to be x minus 5 times x minus 4 is equals to 0. So either x is 5 or x is 4. So the numbers are 5, 4 because if one of them is 5, if x is 5, 9 minus 5 becomes 4. Okay, and if x is taken as 4, 9 minus 4 is 5. So numbers are 5 and 4. Okay, this is the solution. Now let's take a problem on fraction. Question number 9 from the same exercise 5.5. In a certain positive fraction, the denominator is greater than the numerator by 3. That means if the denominator is greater than the numerator by 3, that means if you take the numerator as x, the denominator is greater than the x by 3, it means denominator becomes x plus 3. So we take here, let the numerator n be x, then denominator would become x plus 3 because denominator is greater than the numerator by 3. So the fraction the positive fraction that we are talking about, the fraction would become numerator upon denominator, that is x upon x plus 3. This is the original fraction. The next part of the question says if 1 is subtracted from both the numerator and denominator, the fraction is decreased by 1 by 14. So first of all, let us understand only up to here. If 1 is subtracted from both numerator and denominator, that means it's talking about the change in fraction now. So we find the new fraction here. The fraction is going to get changed by subtracting 1 from both numerator and denominator. So the new fraction would be subtracting 1 from both numerator and denominator. So if I subtract 1 from the numerator, it becomes x minus 1. And if I subtract 1 from the denominator, it becomes x plus 3 minus 1, that is x plus 2. This is a new fraction. And thereby it says the fraction decreased. The fraction means which fraction is talking about? This is the new fraction is talking about. Is decreased by 1 by 14. This means this fraction is decreased means this is smaller. This becomes smaller than the original fraction. And by how much amount it becomes smaller? 1 by 14. So we have to subtract this fraction, the greater minus the smaller. The greater is this one now because it says it's decreased. The fraction is decreased by 1 by 14. So this is smaller now. So the greatest minus the smaller will be equals to 1 by 14, the amount by which it decreases. So the equation would be x upon x plus 3 minus x minus 1 upon x plus 2 is equals to 1 by 14. Children, you need to simplify this equation. You know how to solve? By taking out the LCM. When you take the LCM, we find it becomes x times x plus 2 and minus times x minus 1, x plus 3. The LCM, since the LCM is the product of the denominators, we have to cross multiply the numerator and denominator. Whenever the denominator LCM is the product of denominators, we cross multiply the numerator with denominators. So we simplify this, and be careful about here, it's minus. So when you multiply this, the resultant of this has to be subtracted. So when we simplify this, we will be getting it here as x square plus 2x minus, within the bracket the product of this will be formed, and the product of this is going to be x square minus 1 and plus 3 means plus 2x minus 3, whereas 1 by 14 will be left here, and the product of x plus 3 into x plus 2 is x square, 3 plus 2 is 5, and then product is 6, so it becomes x square plus 5x plus 6. And when we simplify this, you can see that when we simplify the left hand side, plus x square and minus x square will come from here, will cancel, plus 2x and this is minus 2x will cancel, and this plus 3, minus 3 and minus 3 will become plus 3. So you left with 3 here. You left with 3 here multiplied with 14, which will be shifted here. So we will finally have 3 into 14 is equals to x square plus 5x plus 6. And the equation, thereby shifting this multiplication, which is 42. 3 into 14 is 42. So we get x square plus 5x plus 6 minus 42 equals to 0. So the equation will turn out to be x square plus 5x minus 36 is equals to 0. And this equation can be easily simplified by splitting the middle term. Okay, the splitting term, when you split it out, the answer will turn out to be x plus 9 and x minus 4 is equals to 0. And from here, we find x turns out to be 4, where x here will turn out to be minus 9, and we're talking about positive fraction. We're talking about positive fraction, so we take the positive value of x, which is 4. So when you put the value of x as 4 here, so it becomes 4, and 4 plus 3, 7. So when find the fraction means finding the original fraction. So the original fraction, when you put x value as 4 here, 4 plus 4 plus 3, 7. So the original answer will be here. The original fraction is 4 by 7. Okay. So this factorization is very simple, children. That's why I written directly here. You can do it yourself. Moving on to this other type of sum, which is problems on 2 digit. Problems on 2 digit. When a quadratic problem is asked on 2 digit, you will always be given about the product of the digits. You will always be given the product of the digits. So how you are going to go about? Let me read the question first. A 2 digit positive number is such that the product of its digit is 6. That means if you have 2 digit number has a unit place and a tens place, so we take the tens place digit as x and unit digit as y. According to the question, it is xy is equals to 6. And since, children, we have to frame the equation in terms of one variable, we replace y in terms of x as 6 upon x. So y becomes 6 upon x. So now we can write here as y and 6 upon x. Now the question is, if 9 is added to the number, we have to add a 9 to the number. So how to get the number from the digits known at the tens place and the unit place? Tens place digit is multiplied with 10, so 10 into x, plus the unit digit is multiplied with 1, so it becomes 6 upon x. This is the number. This is the original number, to which what is being added? 9 is added to the number. So you have to add a 9 to it. As per the question, number is got by multiplying the digits in the tens place by 10 and plus the unit digit by 1. So we get 6 upon x into 1 is 6 upon x. To this question, to this what we are adding? Plus 9. If 9 is added to the number, we added it. Now what is the result? The resultant is the digits interchange their places. Digits interchange their places means now the tens digit, which was x, comes at the place of unit digit, and the unit digit, which was 6 upon x, comes at the tens place, becomes 6 upon x. The digits interchange the places means you need to write what here? The new number. You have to write here the new number. Digits interchange the places means new number. So how do we get new number? By interchanging the places of digits. Unit digit becomes the tens digit and the tens digit becomes the unit digit. Now the number will be got in the same way. Multiplying the unit digit by 1 and adding to it is the tens digit multiplied with 10. So 6 upon x into 10. So we get 60 upon x plus x. So in place of new number, what shall we be writing here? We shall be writing now 60 upon x plus x. Now shift all the terms towards the left hand side. We equate it to 0 here. We shift x first. 10x minus x becomes 9x. 60 upon x and 6 upon x are like terms. So I shift 60 upon x here, which comes as minus 60. So minus 60 and plus 6 becomes minus 54 upon x and plus 9. Now I multiply the equation by x, where I take x is not equals to 0. So I multiply the equation with x, it becomes 9x square minus 54 plus 9x is equals to 0. Now I rearrange the equation, I get 9x square and divide by 9 also. At the same time I see the 9 is a factor of this, so it can be divisible by 9. I divide by 9 and at the same time I shift the coefficient of x at the middle term, the constant term becomes the third term. So I am doing both simultaneously, dividing by 9 and arranging the terms in order. So it becomes x square plus x minus 6 is equals to 0. And this equation is very simple to solve. It's very simple, we can factorize it. The solution will turn out to be x plus 3 into x minus 2 is equals to 0. And from here you will get x equals to 2. We are not taking x equals to minus 3 because this will give x as minus 3, and with x being minus 3 this number is going to be negative and it talks about positive number, so x has to be positive. So we get x as 2. Find the number means, again, find the number means original number. This means this number you have to find, replacing x as what? 2. Or you can find directly from here, because if x is 2, y is 6 by 2, that is 3. So 2, 3. So number is what? 23. So the answer is, the number is 23. So whenever they ask you to find the numbers and when they ask you to find the fraction, it means they're talking about the original one, not the new one. Is that clear?